Welcome back. Let's take a further look at summary measures that can be used to describe data. And here I want to talk about measures of what are called rank and order, or relative standing. And additionally, while we're here, we'll also take a look at some basic measures that can be used just to give us some very basic values on a data set. So when we talk about rank and order or relative standing, we want to know, where does a given value fall in relation to all of the other observations? And specifically, what we're going to find are values in the data set for which we can say that a certain proportion of the observations have values less than that specific value. And the measures we typically use are things like quartiles or percentiles or deciles. And these names refer to how we define or how we describe or allocate the proportion of data that's less than the value we're looking for. Let's look at this in a bit more detail. These values, these quartile or percentile values, we're breaking up the data set into clusters of equal size. Now, not like we did in a histogram, where we're going to break it up into bins or ranges of equal size, equal width intervals. Here what we're going to do is break the data set into clusters of equal size based on the number of points, not the range of the values. So for example, if I want to find quartile values, my options are to find what I call the first quartile value, second quartile, third quartile, or fourth quartile values. I'm going to break my entire data set up into 4 quarters in terms of numbers of observations. So if I have 1,000 observations, I'm going to look at the lowest or smallest 250 observations, then the next 250 observations, then the next 250 observations, if I have them arranged in order from low to high or from high to low. It's actually specifically in this case from low to high. So my first quartile value would be that value that separates the lowest quarter of observations from the next lowest quarter of observations. Okay? The third quartile value is that value that has 3 quarters of the observations falling below it. The fourth quartile value has 4 quarters of the data falling below it. So that would correspond to the largest value in the data set. And so on. So that's quartiles, the name quart implying we're breaking the data set up into 4 clusters with equal number of points in each cluster. Another way in which we can segment our data set is to break it up into what we call, into 100 groups of the same size. And the boundaries between each of those clusters would be called the percentile values. So for example, we might have the 10th percentile value. That means that 10 out of these 100 groups of equal size, or 1/10 of the data, 10% of the data, fall at or below this value that we're going to call the 10th percentile value. 50% of the observations fall at or below this value we call the 50th percentile. 95% of the observations fall at or below the 95th percentile value, etc. And as you might imagine here, there are 100 possible percentile values. And as we get into very large data sets, we can even, in a way, get more than that. We could have the 97.5 percentile value, if you can conceptualize that. But we'll talk more about those kinds of things later on in the course. But you get the general idea. We're going to break the data set up into 100 groups of equal size to get the whole number percentile values. And key to understanding this is recognizing that when we talk about a percentile, We're talking about a specific value. It's the boundary between these clusters of points, clusters of observations, not the range that they span. So don't confuse the third quartile value with the third quarter of the observations. The third quarter of the observations in a data set of 1,000 observations would refer to that third group of 250 observations. But the third quartile value is the value that separates that third quarter from the fourth quarter. So hopefully you can conceptualize that. And just to maybe drive this home a little bit more and relate it to some things we've already learned, showing on the screen right now are all four of the quartile values we could find for some large data set. First quartile, second, third, and fourth quartile. And also, let's say for the same data set, I'm showing you 4 examples of percentile values, 10th, 50th, 80th, 95th. I could have the 37th percentile value, etc. I'm just showing you 4 examples here. And in all, then, I have got 8 different measures of relative standing shown, the 4 quartiles and 4 examples of percentiles. Well, 2 of those values that I'm showing on the screen, among those 4 quartiles and 4 examples of percentiles, 2 of them would refer to exactly the same value in a large data set. And can you figure out which 2 those would be? Thinking about what they mean and how the data is broken up, it should become clear that the second quartile value and the 50th percentile value should refer to the same value in our data set, because the second quartile value has 2/4 of the data falling at or below it, and the 50th percentile value has 50% of the observations falling below it. So those 2 should refer to the same value. And it turns out we also know that value by another name. If we think back to our discussion of central tendency, well, both the second quartile and 50th percentile value would refer to the same value that we call the median, because obviously half of the observations fall below that median value, or the 50th percentile or second quartile value. Now, in the vernacular, we use these percentile terms quite a bit. We may say that John scores in the 97th percentile on the LSAT. I picked the LSAT as opposed to the GMAT that business school students may take, but John scores in the 97th percentile on the LSAT. What do we mean by that? How do we interpret that? Well, what we're saying is that 97% of the LSAT takers in that same time period, this is the standardized test that people take to go to law school, 97% of LSAT takers in that era had scores lower than John's. So John was a fairly good performer on that test. He was, again, very close to the top of the range. 97% of test takers had scores at or below his score. Only 3% of the test takers scored higher than he did. Now, the way I phrased it in the top bullet is sort of the way we typically say it. But if I had my preferences, I'd say it a little differently. I would say John scores at the 97th percentile value, just to really drive home the fact that that value is a value and not it's not a grouping. It's not in the 97th percentile, but the 97th percentile is really a specific value. But the way we usually say things when you hear people talk about test scores and rankings, they'll say in the percentile. But do remember that we're talking about a specific value and not a range. And if we have a set of observations, we have formula that we can use in Excel to return the percentile and quartile values on a data set. All right. I promised you some basic measures, and these basic measures really are very basic. The minimum value is the smallest value in a numeric data set, and the formula is very simple, equals min. Maximum will return the largest value in a data set, or the fourth quartile or 100th percentile value. And the formula is equals max, and then I select my data set. The range will give me the span covered by my values from the smallest to the lowest. And there's no formula in Excel for the range, but we can easily find it by taking the difference between the maximum and the minimum. All right, well, that takes us through our discussion on relative standing, as well as some very basic measures of the minimum, maximum, and range for our data set.